Okay, class, picking up where we left off at. Remember, we know that there's a perfect square in 20. So we would break that up. We have our negative I times the square root of 3. And we know 20 breaks up into 4, square root of 4 times the square root of 5. So, actually, yes, I needed a little bit more space here. So we had negative I times the square root of 3 all over 2 times the square root of 5. Now we know the square root of 5 has no perfect square in it, so we'll multiply our numerator and denominator by the square root of 5. So we will have negative I times, it'll be square root of 15 all over. We know square root of 5 and square root of 5 is 5 times 2 is 10. So our final answer here would be a negative I square root 15 all over 10. And that is the final answer for C. Now we go here to D. Now, what we could do here for D is this here. First of all, we'll bring the I out front, which will give us I. And then we will have the square root of 2 over 54. Now, we can simplify 2 and 54. 2 and 54 has 2 in common, so this will give us 1 over 27. So now our next step, we will have I times the square root of 1 over the square root of 27. Now, we know that the square root of 1 is 1. All over the square root of 27, the highest perfect square we have in 27 is 9. And we will have 3 left over. So now we will have I times 1 over 3 times the square root of 3. Now, of course, we have to get rid of this square root of 3. So we'll multiply the numerator and denominator by the square root of 3. And this will give us I times the square root of 3 all over 3. Square root of 3 times square root of 3 we know is 9. So that'll be 3 times 3. So now we will have I square root 3 all over 9. And that is our final answer. Now we look here. We have imaginary numbers, numbers of the form bi, and complex numbers are numbers of the form a plus bi. So now we want examples of complex numbers. 22 minus 14i. We add negative 9 plus 6i. We could also have negative 9 plus 0i, which is actually negative 9, or 39i. And remember, it's a plus bi, so our a could be 0 here. So 39i is the same as saying 0 plus, just to illustrate that here. It's the same as saying 0 plus 39i. So that is your a plus bi. Now, we come down here to example 5. It says simplify the following by hand. Write the results in complex form a plus bi if necessary. Now we had 3 plus or minus the square root of 9, which will give us 3 plus or minus 3 all over 21. So what this means is 3 plus 3 over 21, or 3 minus 3 over 21. So 3 plus 3 is 6 over 21, or 0 over 21. Now 6 over 21 we know simplifies to 2 over 7, or 0 over 21, which is 0. So it's 2 sevens or 0. Next, we add 3 plus or minus the square root of negative 9 all over 24. So we add 3 plus or minus, we know the square root of negative 9 is 3i all over 24. So what we could do is this here. We could factor out a 3, and we will be left with 1 plus or minus I all over 24. This 3 and 24 both has 3 in common. So we know 3 goes into 3 once, 3 goes into 24 8 times. So our final answer would be 1 plus I, 1 plus or minus I, all over 8. Now we come down here to C. Now we had negative 4 plus or minus the square root of 40. So we had negative 4 plus or minus, the highest perfect square in 40 is 4. So we had square root of 4 times square root of 10 all over 2. So we will add negative 4 plus or minus 2 square root 10 all over 2. Now we can simplify this. 2 will go into this negative 4 and this 2. So 2 goes into 2 once, 2 goes into negative 4, negative 2 times, and 2 goes into 2 once. So we would end up with negative 2 plus or minus. We don't have to write the 1 with the square root of 10. So we add negative 2 plus or minus the square root of 10 all over 1, which is just negative 2 plus or minus the square root of 10. And we're done. Okay, now we come to D. We have here, we have negative 4 plus or minus. Now we know the square root of negative 160 will give us I, because we would get rid of that negative sign, times the square root of 160 all over 2. So this will give us negative 4 plus or minus I. Highest perfect square in 160 is 16. So we add square root of 16 times square root of 10 all over 2. So it'd be negative 4 plus or minus. Now we know the square root of 16 is 4, so that would make that 4I square root 10 all over 2. Now I'm going to do what I didn't do in the last problem. We can use factoring here. Negative 4 and 4I both has 4 in common. So we could simplify out 4. And that will leave us a negative 1 plus I square root 10 all over 2. Now we know 4 and 2 can simplify. 2 goes into 2 once, 2 goes into 4 twice. And all we would have to do is multiply 2 by everything in the parentheses. We have negative 2, and it's supposed to be plus or minus I. Well, actually it should be 2I square root of 10. And that is our final answer. So negative 2 plus or minus 2I square root 10. Now we get down here to E and F. Now, with E, we have negative 8 plus or minus the square root of 1200 over 40. So we add negative 8 plus or minus. The highest perfect square in 1200 is 400. And times 3 times the square root of 3 all over 40. So now we will add negative 8 plus or minus. The square root of 400 is 20. Square root 3 all over 40. Now we could do it like this. The common factor of 8, 20, and 40 is 4. So 4 goes into 40 10 times. 4 goes into negative 8 negative 2 times. And 4 goes into 20 5 times. So our final answer would be negative 2 plus or minus 5 square root 3 all over 10. And that is our final answer. Now we go here to F. Now if you notice here, we will add negative 4 plus or minus. Now we know since this is negative under a square root, we'll pull out our I. And then our highest perfect square in 128 is 64. We have 2 left over. And that's all over 20. So we add negative 4 plus or minus. The square root of 64 is 8. So it'll be 8I square root 2 all over 20. Now if we look here, negative 4, 8i, and 20, they all have 4 in common. So 4 goes into 25 times, 4 goes into -4, -1 times, and 4 goes into 8 twice. So our final answer here would be -1 plus or minus 2i root 2 all over 5. And that is our final answer.